Hello students. So in this video we are going to see constraint equations, how to develop constraint equations and how to solve questions on pulley, strings, right? Very basic level, J main level. Okay, let's start. So there are three types of constraint, right? Constraint motion. So constant motion means the body is free. Body is not free to move in other direction. It is only going to move in a particular direction. Constant motion means the body is restricted to move in a particular direction. Okay, let's take example. So suppose if I take inclined plane or wedge, this is the wedge, right? And this wedge is, let us say, fixed, and there is a block which is kept, and let's say this is a smooth surface. All these surfaces are smooth. So what is going to happen here is this block, which is kept on this. If you release it, it will go down. It can only move in this direction. So the block is constrained to move along the wedge. Okay, so this is the block. So here the block is constrained to move only along the inclined plane. That means it has to move only either down or up. It can move, right? Perpendicular direction it can never move. Perpendicular direction it must be balanced, right? So perpendicular direction or other direction, the forces should be balanced. That's why we resolve forces when you consider motion along that. So we have to resolve forces along the plane and perpendicular to plane, right? That's why we resolve forces like this. And perpendicular to plane we balance, along the plane unbalanced forces we add up, and then we apply Newton's second law, net force is mass into x distance, right? This very basic type of this is called wedge constraint. This is known as wedge constraint. Okay, this is one type of constraint. Suppose the wedge is not fixed. Here of course it is fixed, but if the wedge is not fixed, then relative to the wedge the block has to only move up and down along the inclined plane. So in another case you can consider this, the block and wedge both are free to move, and when you release the block the wedge may go in another direction, right? So the relative motion of the wedge and block with respect to wedge will be fixed. And let's take that example. It's a good example, but that is mostly going for advanced. In main they may not that. Okay, suppose this is a wedge. This is a smooth surface and it is free to slide. So this wedge is constrained to move horizontally, right? And when you are keeping a block here like this, let's say that you keep a block. Okay, so when you release this block, so with respect to the wedge, it can move in this direction, either this direction or this direction. Okay, so the block is constrained to move over the surface of the wedge. This is the wedge and this is the block. Okay, so motion or acceleration of the block with respect to wedge will be along the inclined plane. Okay, and acceleration of the wedge will be either this or this. Any direction you can say, because we don't know what is the net force, right? So this horizontal direction will be the acceleration of wedge with respect to ground. Of course, ground is not moving, so this is the acceleration of wedge. Now if you want to actually find acceleration of the block, okay, let us say, now take a question, a condition. Suppose you release the block, what will happen? The block is going to move down like this. This is the acceleration of block with respect to wedge, and the wedge will move in this direction, acceleration of wedge. So if you want to calculate the acceleration of this block, you need to add these two vectors. Okay, you should know these two vectors. When you add, then you can get it. So let's do it like this, vector addition. This will be actually the acceleration of block, because this is of course vector addition, right? Acceleration of block with respect to this. So acceleration of block with respect to wedge plus acceleration of wedge we have to add. And what is this angle? No, we can understand what is this angle, because this direction is this angle making theta, right? So obviously this angle will be 180 minus theta, 180 minus. So if you know these accelerations, this block with respect to wedge and acceleration of wedge, then you can add the resultant. That will be the actually acceleration of block with respect to ground. Okay, that's the absolute acceleration. This is how we calculate. Now the thing is that you can use this way to solve problems, right? And you need to calculate acceleration of wedge and acceleration of block with respect to wedge by seeing the resultant force by mass. You can do that. Okay, now there is an important thing of constraint equation. You need to note that how to balance the forces and how to balance the acceleration. Okay, so let us say that if this is the acceleration of wedge and the block, suppose they have given, then how do we balance it, or how do we get relationship between them? Here in this diagram, this is the acceleration. Okay, now let us say that this is the actual acceleration of block, okay, with respect to ground. Let us say that this acceleration is making angle. Now I will just write the actual acceleration of the block. The block, actual acceleration of the block is, let's say, making angle alpha with the horizontal. Okay, alpha. We don't know what is alpha, but of course from here we can calculate that angle alpha. Remember, tan alpha can be calculated from here. How? Tan alpha is b sine theta. B means here they say the respect to, right? B sine theta. Sine theta means 180 minus theta. B sine theta by a plus b cos theta. Okay, right? Remember this formula. So using this, of course, we can get some idea about tan alpha. But let us say that this is tan alpha here in this diagram. So it is not that this acceleration of this block is perpendicular to the wedge. It may come something, but let us now consider this direction which is along the inclined plane. And now what we can do is, instead of taking this as alpha, let me consider some other angle. Let me say that this acceleration of actual acceleration of the block is making some angle, phi, let us say, with the normal. Let me say that this is the normal. Okay, normal to the plane. So with this it is making some angle phi. So we can resolve this acceleration along this normal. Let us say this is acceleration of b cos phi, it will be, and this will be acceleration of b sin phi, right? Along the normal we should try to resolve. Then also What about the wedge? Of course, wedge acceleration is this is the wedge acceleration. Let's say acceleration of the wedge. Now this acceleration of the wedge can also be resolved in the normal direction, okay, like this. This is of course normal. So we know that this angle is also theta only, right? Because this is theta. So you can resolve this in this direction, which will become AW wedge cos theta, and this will become acceleration of wedge sin theta. Here this is the important point to note. Now this is the important point. The acceleration of the wedge along the normal and acceleration of the block along the normal must be same. That is what is constant, because the point of contact, wedge and block are in contact, so in that direction they cannot have relative acceleration, relative motion, perpendicular direction. That is why this acceleration of b cos phi must be same as acceleration of wedge sin theta. Okay, so this is what we should know. This is very important thing. Okay, so this is what is the wedge relations, constraint equations. You can see this is constraint equation which gives relationship between accelerations. Okay, that's the important thing. Then let's go to the next. Then we'll go to see some other type of constraint also. One example, another example. Let's take that there is a block which can move only up and down. Let us say this is a block which can move only up and down, or maybe we should draw a small like this. Let us say like this. Only portion of it I'm drawing. Okay, and this is like you can extend it like this, but this would be like a exactly straight line. Suppose this is like this. Okay, this is a wedge and this is another like this. Now you can see this is also a constant, right? This object can only move up and down. Okay, this is a wall constant and this can only move horizontally. Okay, let us say that this is going down with the acceleration a, right, and this is going in this direction a1, this is a2. So what is the relationship between a1 and a2 we have to understand. So this acceleration which is a1 we have to resolve along the plane perpendicular. Only perpendicular component we should take, right? So we should know that this angle is also theta. So this direction component is a1 cos theta. Okay, a1 sin theta is also there, a1 sin theta, but we are more interested in a1 cos theta because this is along the normal. Now if you take this wedge acceleration in this direction is a2. Here also we should try to draw this surface and perpendicular to this surface. So resolve like this. Again this is theta, so this will be a2 cos theta and this will be a2 sin theta. Again here the constant relationship means a2 sin theta and a1 cos theta must be equal. Perpendicular direction, there is no relative motion because this contact surface never leaves. So in this direction we should know that the same acceleration both the object must be along the normal. Along the normal, this contact surface or contact point must have same acceleration. Okay, so that's why a1 cos theta is equal to a2 sin theta here, and you can understand that a1 becomes a2 tan theta. Okay, a1 becomes a2 tan theta. It's an important relationship, right? a1 is equal to a2 tan theta. This is example of constant motion. Then I think now we can go for pulley system. Let's go for pulley system. Little bit complex pulley system we'll take. Okay, so let us say that this is a pulley like this. Single pulley we have already known, but we'll take more than one pulley, right? Let's say this is a string and there is one block here. Then this string is coming. You can draw another pulley here. Okay, and this string is passing over it. Let's see, it is going like this. And if you want, you can fix it. If you want, you can put another. Let's keep just only 2 pulley for simple case. Okay, like this. This is fixed again with the valve. Okay, so now the question is, there is one more block attached here. Okay, let's say one block is attached with the pulley. Okay, like this. This is block 1, this is block 2. Okay, so mass is m1, m2, corresponding mass. Now, what is the relationship between acceleration? So, 2 methods are there. Shortcut method we'll discuss afterward. First, we understand the basic. Suppose this is first. So, let's say that this is a fixed line. Okay, fixed point. Of course, this pulley is fixed here, so this point is not going to move. So, this is pulley P1 you can take, and this pulley P2. Okay, so pulley P1 is fixed. P1 pulley is fixed, and P2 pulley is movable. It is moving, right? It is moving. So anything which is moving, we will write its relationship like displacement and all that. So let's write from the fixed point. We have made this fixed point as P1. So this is the you can say position of P2. Position of P2. Position of this pulley. Okay, this is position of the block 1, and this one is the position of block 2. Okay, now we can write the length of this string. Remember, the string length does not change. So this length, this length, this is one string, right? So the length of this string will be constant. Let's say this string length is L1. So this is made up of what? X1. And this curved part you can leave. The curved part is always fixed, that you leave. Then this part, which is pulley position P2 plus then again 2 times, no, it is coming x of P2, right? And then this part is anyway constant. So this is going to be constant. So you can write this as x1 plus 2xp2 L1. This is one equation. Similarly, you write position x2. So that means the second string, this string length will be L2. So what will be that length L2? That length L2 will be x2 minus xp2, right? You can multiply this 2 times. So 2L2 is equal to 2x2 minus 2xp2. This is second equation. Now add both these equations. Add first plus second. First plus second, when you do, you will get L1 plus 2L2. xp2 terms will get cancelled. That's what we want. We don't want to study fully. Remove that. So you get relationship between them. Now when you differentiate this, these are all constant, right? The length of this string. So differentiation of this will become 0 left side. Here differentiation of x1 with t plus 2 times differentiation of x2 with t. Now this x1 differentiation is nothing but velocity of first and 2 times velocity of second. Okay, is equal to 0. So from here we can say v1 is equal to minus 2v2. Minus is just showing the direction. One is going up, another is going down, or the lengths are increasing or decreasing, right? So this equation is important. Then you further differentiate, you will get acceleration e1 is minus 2 times acceleration e2, right? This approach is constant motion approach, and we can definitely go through it, but it's a little bit lengthy, right? Lengthy. What is the shortcut for this? Shortcut for this, we should know about the virtual work or work done by tension, internal forces. Okay, so work done by internal forces are 0 here. Let's first see tension. So if I take this as tension, this also tension, this also tension, this pulley is balanced, so there will be 2T tension here. Okay, so this is going up. Let's say this tension is acting in this direction, right? And here pulley tension, police balance, no need to study police. This here, let's see the blocks. Okay, blocks. So take the product of tension and displacement. Suppose if I take this tension and this displacement x1, right, plus tension is 2t on the block, second block, displacement is x2, okay, is equal to 0. The sum of all this work done by internal forces, work done by internal forces is equal to 0. So this is the work done by tension, right? Tension will get cancelled, you will get x1 is equal to minus 2x2. Now if you differentiate, you will get v1 is equal to minus 2v2, and further differentiate, a1 is equal to minus 2a2. Isn't it? It's like, very shortcut. So finally this relationship of accelerations can be obtained in a much shorter approach. Going by constant equation is much longer approach, right? So we can apply this. That's the best way to do that. Okay. So why do we get the relationship of acceleration? Why? Because then we can study about its, we can then do the calculus. For example, now let's say that this a1 and a2 are related like that. So now let me just consider that this is going down with acceleration a1. So it should go upward direction, right? So it is upward, magnitude is a2, upward. Now see, first when I am going to write the Newton's law here, so we will write this is m1g, here also m2g, forces acting. Now if I am going to write on the magnitude wise, you can say a1 is equal to 2a2, okay, by magnitude. Now we are going to just take by magnitude only the equations, right? So now let's understand important thing that if I draw Newton's second law, if I apply the first one, it is going down, so I will write equation m1g minus t is m1a1, right? Similarly, I will write equation on this second 2t, because it is going up, 2t minus m2g is equal to m2a2. Now what I am going to do is I am going to substitute here m1 as, by magnitude I am substituting, so this will become 2 times m1 a2, right? So what I will do is I will multiply this equation with 2, so it will become 4t minus 2m2g is 2m2 a2, right? Now you can see this equation and you see this equation, right? You can subtract it, right? Let us say that this equation is equation number 3 and this is equation number 4. So you may equate it both of them, or you can subtract it both. Let's equate it. So 4t minus 2m2g becomes equal to m1g minus t. From here you can calculate tension. This will become 5t, right? And m1 plus 2m2 will come common, g divided by 5. This will be the tension T1. Once you calculate tension, you can calculate acceleration by substituting in any one of this equation. Let's say you put in the first equation, so there you will calculate acceleration a1. How will you calculate a1? So a1 will be g minus t by m1, right? So if you substitute here, it will become g minus t. You got this one, so m1 plus 2m2 by 5 m1 times g, right? If you further simplify it by taking common, so let's take common, so 5 m1 and this will come as g, and here 5 m1 minus m1, so that will become 4 m1 minus 2 m2, right? This will be the acceleration a1. Once you calculate this acceleration, then this a2, we have got relationship that a1 is 2 times of a2, so a2 is half of a1. a2 will be half of a1. So you can see we can calculate all the important things, tension, acceleration, constant motion. But to get constant equation, better to use that internal forces work done 0, this concept. So the whole purpose for this calculation is to find out tension and acceleration. In a complicated system, we can use this. Okay, I hope you have understood this. This is the main concept here. It won't go beyond this in JEE level. Okay, so that's what it is. Then what else? I think we have done, and there are some certain constraint like this example, famous example. You should know, like this is a pulley, two pulley, and this somebody is pulling a object which is like hanging in this manner. Okay, like this. So let's say this pulley is of course fixed. Okay, you can see this is fixed here. This pulley is also fixed. Okay, so the distance between the pulley is, let us say, d, or 2d you can take. So this become d and this become d. Okay, so this is a constant. Now here this is the going with the speed u downward. So what is the speed with which it will go up? That's the question. And at a particular instant this angle is making theta with the vertical. Okay, how do you calculate it? You cannot apply the resolution concepts here. You have to be very careful here, because resolutions concept will confuse here, right? Apply the concept of constant motion. Okay, so first of all you have taken, let's say this is the reference line. Okay, and let us say that this distance from here to this distance is going to be constant, not constant, this will be variable. I will show this side. Okay, this is the distance, let's say y. This is the distance of this object block, right? That will be changing, isn't it? This will be changing. So as we are pulling it, now let's say this r is the length of the string from here to here, right? So this is the length of this string. This length r is changing. At what rate r this length is changing? At the rate at which we are pulling it. Okay, so dr by dt is same as u. U is the rate at which we are pulling this. Okay, here we should understand that if you take this triangle, just let's take half of this triangle. Okay, this distance is y, this distance is r, and this distance is d, and this distance is theta. Okay, so here r square is equal to y square plus d square, Pythagoras theorem. Now you differentiate with time. So differentiate this side with r to r, dr by dt, dr by dt you will get. Here similarly 2y, dy by dt you will get. And differentiation of d is 0. So from here r dr by dt is u, and then this side will be y, dy by dt is v. So from here you will get v is equal to u divided by y by r, right? Now what is y by r? That is cos theta, isn't it? So u by cos theta. This is what you have to understand. By constant equation you get this equation, right? Okay, so this is the application of this. Lot of such applications are coming in JEE. You should be thorough with this topic. Okay, right. Then further we will be taking up in the next class. Okay, thank you for your attention.